Hello and welcome to CCNA Subnetting Video 4. This is the fourth of 8 videos that come as part of the ICND1 and ICND2 official exam certification guides from Cisco Press. This video shows how to find the broadcast address and the range of addresses in a subnet, and it's the first of 3 examples of how to do that. Videos 4, 5, and 6 show 3 different examples of this process. This video shows how to find the broadcast and range of addresses for subnet 128.200.96.0 with mask 255.255.224.0. This video has 2 main objectives. First, the tactical objective is to help you understand how to use a particular process to find 2 pieces of information about a subnet: the subnet broadcast address and the range of valid addresses that can be assigned to hosts in that subnet. To fully understand the process that's shown in this video, you need to know a related process that's used to find the subnet number. If you've not done so already, you might want to watch Subnetting Video 1, which shows how to use that process, or at least have read about it in the Cisco Press CCNA exam certification guides. The ultimate goal for this video is to help you prepare to answer subnetting questions on the CCNA exams, particularly that you're able to answer them quickly and with confidence. Now, once you've finished this video, you need to do some practice. The process you see in this video gives you some structure with which you can do the practice, but if you practice enough problems, then you'll internalize the process. So while this process is very useful for learning, if I were to meet you one day, I wouldn't want to hear you say, "Hey, that process you gave us, process number X, step number Y, that was a really cool step." No, what I prefer to hear is something like, "Hey, I used your processes and practiced those, but after a while I saw all the patterns. So then come exam day, I could look at a problem with an IP address and mask, and in 10 seconds flat, figure out the subnet number, broadcast address, and range of valid addresses in that subnet." Next, for context, I need to give you a little bit of background about the specific process that's described in this video. The Cisco Press CCNA exam certification guides describe several processes with which to find the answers shown in this video: the subnet broadcast address and the subnet's range of valid addresses. Now, this video focuses on a single one of those processes, namely the process that's used when the subnet mask is a difficult mask and you don't want to use any binary math. Now, a difficult mask simply means that the mask has one octet that's neither a 255 nor a 0, which makes the answers a little bit less intuitive. Now, the books refer to this particular process as reference page 6C or RP6C, and that's just to be able to have a name for the process as compared with other ones that do use binary math or use a simpler mask or a process that finds the answer to a different question. Next, before seeing the process, let's take a look at this idea of a subnet broadcast address. A subnet broadcast address is one single address in each subnet. When used as a destination address in a packet, causes that packet to be broadcast to all hosts in that subnet. Now, because it's used for broadcasting, it cannot be used or assigned to a host to be used as a unicast IP address. So it helps to see an example. For instance, here, PC2 is going to send an IP packet to address 128.200.127.255, which is the subnet broadcast address of the subnet on the left. So let's take a look at what happens. First of all, PC2 sends its packet, and as usual, PC2 says, "All right, this packet is destined to an address in a different subnet. Let me send the packet to my default gateway, in this case R2. R2 makes a simple routing decision and says, "Oh, the subnet that this address is in is on the left. Let me send this packet over to R1. Now R1, when it gets the packet, thinks, this address is actually a subnet broadcast address on the subnet connected to my LAN interface. So when R1 forwards the packet, R1 encapsulates the packet in an Ethernet frame, but sends this Ethernet frame as an Ethernet broadcast. As a result, this Ethernet broadcast frame goes to all devices on the LAN, including PC1 and PC3, so both PCs get a copy of this particular broadcast." Next, just to be clear, let me define what I mean by range of usable IP addresses. First of all, the subnet number itself cannot be assigned to a host to be used as its unicast IP address. And as we just saw, the subnet broadcast address cannot be assigned to a host either. However, all the numbers in between the subnet number, which is the smallest number, and the subnet broadcast address, which is the largest number, all the numbers in between there can be used. For instance, this video shows an instance with a subnet number of 128.200.96.0 with a mask of 255.224.0. Now it turns out the subnet broadcast address in this case then will be 128.200.127.255. So the first assignable address is simply one bigger than the subnet number, as you see here, and the last assignable address is simply one less than the subnet broadcast address, as you see here as well. For easy reference, the screen now shows a copy of the text of the process that will be demonstrated in this video. Notice that this process starts with step 5, and it's numbered this way because the associated process that finds a subnet number has 4 steps, so this process just picks up where that other process stops. The process shown in this video, process RP-6C, assumes that you use process RP5C to find the subnet number. Now, if you're not yet familiar with the RP5C process, Subnetting Video 1 shows how to find the subnet number about which we're now going to find the broadcast address and range of valid subnets. Finally, we're going to show the example of how to find the broadcast address and range of valid addresses. What you see on the screen now is an example of an IP address in that subnet and a mask, and the end results of process RP5C, which found the subnet number you see there, 128.200.96.0, with space left in the table for the first IP address, last IP address, and broadcast address for this subnet. So to begin process RP6C, we start with step 5, and step 5A in particular says, look at the mask octets whose value is 255, or visually, look at the octets to the left of the rectangle. For those octets, we simply copy the subnet number's value down to the broadcast address. Simple enough. Then for any octets fully to the right of the rectangle, or octets whose mask value is 0 if you prefer, we're going to write down a 255 in that octet of the broadcast address. So, in step 5A, we copied the subnet number octets, and in step 5B, we wrote down 255s in the octet to the right, leaving a single interesting octet to figure out the value for. At step 5C, to figure out the broadcast address's value in that interesting octet, we take the subnet number's value in that octet, add the magic number, and subtract 1. The math obviously is pretty simple. We end up with a 127 in that octet, which gives us the final answer of broadcast address 128.200.127.255. Next, for completeness, I'll show the very simple math about how to find the first IP address and last IP address in the range of valid addresses. Step 6 of this process says to find the first IP address in the range of valid addresses, start by copying the first 3 octets of the subnet number. Doesn't matter where the rectangle is, just copy the first 3 octets, and then add 1 to the 4th octet of the subnet number. So as you see here, you take 0 plus 1, of course, is 1, giving us a first valid IP address of 128.200.96.1. Step 7 finds the last valid IP address in the range of addresses based on the subnet broadcast address value. For step 7, similar to step 6, we copy 3 octets, but in this case we copy the first 3 octets from the subnet broadcast address. Then for the 4th octet, you simply subtract 1 from the broadcast address's 4th octet. In this case, 255 minus 1, of course, is 254, which gives us a last valid IP address of 128.200.127.254. This concludes this video's example of how to use process RP-6C to find a subnet broadcast address and range of valid addresses. However, before finishing up the video, I need to let you know about a couple of the IP addresses in that range that may cause you problems when you look at it on the test. In particular, consider the addresses you see here, 128.200.96.255, 128.200.97.0, 97.255, and 98.0. Many people might look at those numbers and instantly think that the ones that end in 0 are subnet numbers, and the ones that end in 255 are subnet broadcast addresses. Well, all these numbers are valid assignable IP addresses. You can configure them on hosts in the subnet that we just looked at, and they work just fine. So, try to resist the temptation to make assumptions about dotted decimal numbers, particularly because not all numbers that end in 0 are subnet numbers, and not all dotted decimal numbers that end in 255 are subnet broadcast addresses. It's a good idea to go ahead and practice this same process with 2 additional problems right now. Here on the screen you should see those 2 additional problems, so go ahead and work those. Then if you want to make sure you're using the process correctly, you can watch videos 5 and 6, which show how to work these two problems. Once you see those, it's a good idea to practice more until you perfect the process. And of course, don't forget, both the IC&D 1 and IC&D 2 books in Appendix D have some additional practice problems. Hello and welcome to CCNA Subnetting Video 5. This is the fifth of 8 subnetting videos included with both the IC&D 1 and IC&D 2 official exam certification guides from Cisco Press. This is the second of 3 videos that show an example of how to find the subnet broadcast address and range of assignable addresses in a subnet given the subnet number in a mask. In particular, this video shows how to start with subnet number 10.99.88.0 with mask 255.255.248.0 and find the subnet broadcast address and range of addresses. The first objective for this video is to examine a particular process for finding both the subnet broadcast address and range of valid addresses. This video picks up the same problem that was begun in subnetting video 2, which showed how to start with an IP address and mask and find the subnet number, with this video now taking that subnet number and finding the subnet broadcast address and range of valid addresses. And as with all these subnetting videos, the strategic objective is to help you prepare for the CCNA exams so you can do subnetting questions quickly and with confidence. For easy reference, the screen now shows a copy of the text of the process that will be demonstrated in this video. Notice that this process starts with step 5, and it's numbered this way because the associated process that finds a subnet number has 4 steps, so this process just picks up where that other process stops. Feel free to go back and watch subnetting video 2 at this point. However, for a brief review, that video started with IP address 10.99.88.77 with mask 255.255.248.0. That process showed that the interesting octet was the third octet and that the magic number was 256 minus 248, or 8. So finally, let's take a look at this particular example. We've expanded the table so that instead of just listing the mask, IP address, and subnet number, it lists an open space for the first IP address, last IP address, and broadcast address. So let's take a look at the broadcast address first. At step 5A, we see that we should look for any octets to the left of the rectangle, and for those octets, copy the subnet number's value down to the broadcast address. In other words, the subnet number and broadcast address are going to be the same in the octets to the left. Then we look for any octets to the right of the rectangle, and for those octets, simply write down a 255 in the broadcast address. Now that leaves us with one open octet, and that's where the tricky part comes in. So what we do is we take the subnet number's value in that octet, 88 in this case, and we add the magic number of 8 and subtract 1. Now the resulting value 95 is the value in the third octet of the broadcast address, which gives us a subnet broadcast address of 10.99.95.255. Once you know the subnet number and subnet broadcast address, finding the first and last IP addresses in the subnet is simple, but for completeness, I'll show it here. First, to find the first IP address, you copy the subnet number's first 3 octets, doesn't matter where the interesting octet is, and then add 1 to the 4th octet of the subnet number. In this case, we've got a 0 in that octet, so 0 plus 1, of course, is 1, giving us a first IP address of 10.99.88.1. Next, it's step 7, to find the last IP address in the subnet that can be assigned to a host. You start with the broadcast address. So here at step 7, you copy the first 3 octets of the broadcast address into the last IP address field, ignoring the location of the interesting octet. Then you subtract a 1 from the last octet of the broadcast address. So in this case, we have 255 minus 1, which of course is 254, giving us the last valid IP address, the last IP address in the range that can be assigned to hosts of 10.99.95.254. Now at this point you should try to practice this process until you can get the answer to what's the subnet broadcast address and what's the range of addresses in say 5 to 10 seconds. So go ahead and try this additional problem now if you like. Then you can watch video 6, which shows how to find the answer to this problem using this same process. And as usual, you can go to the IC&D 1 or IC&D 2 book and look at Appendix D for additional practice problems with explanations of how to use this process to find the answers.